Station, this is Houston. Are you ready for the event?
Houston Station, we're ready for the event.
National Public Radio, this is Mission Control Houston. Please call station for a voice check.
Station, this is National Public Radio. How do you hear me?
Got you loud and clear. Good to talk to you today, Ira.
That's great. Thank you. We're very happy to talk to you. Can you both hear me okay?
We've got you loud and clear.
We used to say in the old business 5x5 or something like that when I was a ham radio operator or something.
5x5 works.
All right, let's begin. Let me ask you, Don, first. Does the view in space ever get tiring as you look out the windows?
It never gets tiring to view Earth from space or space from space, just like any number of views from Earth of Earth never get tiring. To see a sweeping mountain scene never gets tiring. There's something about natural beauty that is inspiring to myself, and I will generalize to human beings.
What question do you get asked most by people besides the bathroom question? We'll do away with that one. What question do people want to know most about your experience in the space station?
One real common question is what I miss most from Earth being up here for a 6-month mission. And one real astute student asked me the inverse question: what will I miss most from space once I return to Earth? So I thought that was a very clever play on one of the standard questions that people ask you.
Mm-hmm. Dan Burbank, you were recently evacuated from the space station because of what turned out to be a close call with space debris. Give us an idea of what that experience was like.
Well, we actually had a pretty good heads up about it. We've got tracking radars all over the world that keep track of orbital debris, and it's things that are basically, in rough order magnitude about the size of your fist or bigger. And there are tens of thousands of things that are tracked. And whenever one gets kind of close to space station, if we have ample time, we will actually move the space station. We'll actually do a burn, a debris avoidance maneuver, if you will, and it'll open up that distance to something a little bit more comfortable. Every now and then we'll get something that's either small enough that it only crops up very late, or it crops up in such a way that the accuracy is a little bit unknown. And in this particular case, it was kind of a combination of both. There was a lot of uncertainty in it, and it was also very late. There wasn't time to actually do a burn that would have been effective in opening up that distance to something more comfortable. So for us, we talked about it the night before, actually probably a day and a half before, and we knew there wasn't time to do the burn. And certainly in the 12 or so hours leading up to what we call the shelter in place, we discussed what we'd have to do. And from our perspective here on board, it was actually fairly straightforward. We essentially started from the forward part of station, worked our way back aft to where the Soyuz vehicles are located, and we powered down systems. And the ground did an awful lot of the systems work there, and we closed all the hatches to isolate as many of the modules as possible from each other. And then we just waited until the closest point of approach with the debris item, and we were each in our respective Soyuz capsules.
Mm-hmm. There have been a couple of big solar flares recently that sent lots of potentially dangerous charged particles toward the Earth. What precautions do you have in the space station to shield yourselves from them, and are you in any real danger?
Earth, we're outside of the atmosphere, so we don't have the protection from Earth's atmosphere like you would on the surface of Earth. However, we're still well within Earth's magnetosphere, and that deflects a lot of these particles so that they don't pose a real threat. We do have a higher level of radiation up here, but we're still very much under the protection of Mother Earth, and with very few exceptions, life just goes on normally on space station with or without a solar proton event. And what we do notice, these events bring out wonderful displays of aurora.
Let's talk about some of the interesting experiments that you folks are doing up there. One in particular that interests me is a flame experiment. We all know what a flame looks like on Earth here and how it behaves. But from pictures I've seen in zero G, it looks totally different. And how are you experimenting with it?
Well, one of the racks, this rack right here, is a combustion rack for investigating various combustion processes where you're looking at the nitty-gritty details of how flames burn. The rack right next to it is a glove box where I currently have a flame experiment set up there. And basically, flames have a healthy appetite for oxygen, and they get that oxygen literally by fanning the flame, and gravity helps fan the flame because of gravity-driven convection. The flame is hot, the hot air rises, cold air rushes in, and that brings fresh oxygen next to the flame. If you try to burn a flame in weightlessness with no air motion around it, it'll burn for a few seconds and snuff itself out. So the whole dynamics of what happens with flames is different in a weightless environment, and so the microgravity environment here on Space Station is a wonderful place to investigate fundamental aspects of combustion. It's basically another experimental knob we can tweak and help figure out what's going on when something burns.
And you're saying that if you leave the flame to itself, it will snuff itself out. That's something unexpected.
It is, and I was doing some combustion experiments last week where we were burning little spheres of plastic. They were polymethyl methacrylate. It's the clear plastic that UC-Thade's made out of. And we were burning spheres of that. And we were going to, we had a fan blowing on it to add convection. We're going to put the flame out by purging it with nitrogen, which should stop the flame. It turns out it didn't stop the flame because the nitrogen entrained enough air in it that it just kept feeding sufficient oxygen to the burning plastic. And what snuffed the plastic out in a matter of seconds was turning the fan off, and the flame consumed all the oxygen around it, and it just went out on its own. And I tell kids this is the space equivalent of what we tell our school kids of stop, drop, and roll if you happen to catch on fire. But the space version of that is stop and float. And of course, you don't need to drop because there's no place to drop to.
Very, very interesting. Let's talk about another experiment. Is it true that you have like a little distillery up there in space? You're doing a sort of a malt experiment? Are you going to brew some beer or something for us?
I heard about that, but that experiment hasn't made it on Space Station yet, and I don't really know what the details are. I think it's just bringing some materials up and maybe mashing them and then bringing them back down to Earth. I don't think there's any plans for distilling. However, we do have a distillation process here on Space Station, a distillation apparatus, and can you guess what we distill with it there?
I'm afraid to ask.
Okay, it's part of what we call our regenerative life support system, which I like to refer to as the coffee machine, and it consists of 3 pieces of equipment. We have a toilet. We have this big piece of equipment that the toilet is plumbed into, which contains a distillation apparatus, and then we have a galley. And you go in and use the toilet, and then this big piece of equipment goes chugga, 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 and then you go to the galley and you get yourself a bag of coffee. And so I like to refer to this as a coffee machine because it takes yesterday's coffee and turns it into today's coffee. And the key element, one of the key elements in that is a fractional distillation process. And a normal process like that wouldn't work in a weightless environment because all our stills on Earth require gravity to separate the vapor from the liquid. And this uses rotation. It uses a rotating body to help add centrifugal force to separate the vapor from the liquid and perform the distillation. So it's really a neat piece of engineering research.
Very, 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 very interesting to learn how that works. Dan Burbank, what are you hoping to learn through your integrated cardiovascular experiment?
Well, that's an experiment that's got a lot of different aspects to it, and fundamentally, the main goal is to understand how humans adapt to the weightless environment of space, and how we can mitigate the negative effects of that. So for all of us here, our bodies are just as strong as they need to be for the environment that we're operating in. So if we don't exercise and we're on planet Earth, we will get flabby and we'll lose muscle mass. If you're up here in space and you don't exercise considerably, since you're never counteracting the force of gravity walking around as we would on Earth, up here you would lose a lot of muscle mass, you'd lose a lot of minerals from your bones, your heart volume, the size of the heart muscle would get smaller and smaller, and those would all be fine if you were going to live and essentially be a long-term creature of space. But since we're going to return to planet Earth sometime, we'd like to minimize that as much as possible. So integrated cardiovascular kind of looks at a holistic in a holistic way at how the body adapts to here. And we do everything from ultrasound, where we're scanning our hearts and our blood vessels. We've got a lot of exercise components to this. We're doing blood pressure and 24-hour, actually 48-hour electrocardiogram to understand how, from an electrical standpoint, how the human body is changing. And all these things will help us leave low Earth orbit and go on into deep space, to go back to the moon long term and to go on to the asteroids and Mars. And I think that's a key part of what space station can do for us.
I had heard that there had been some talk at NASA. I was reading about it this week, and maybe you can talk about it. About using the space station as a simulation for going to Mars, a sort of a long-term simulation mode of what the trip would be like and how it might affect your body. Can you talk about that at all?
Yeah, there's a lot of discussion about it right now, and that's a really interesting part of it. One thing that's fundamentally different about what we do here on Space Station and our experience here on Space Station from what it would be like to go to the moon long term and certainly to go to Mars. Now, rough order of magnitude, the moon's about 1,000 times further from the Earth than the Space Station. Mars is about another 1,000 times further, than the moon is. So you've got a lot of different aspects to what it's like to leave the close confines of planet Earth. Here we essentially have a permanent logistic stream from Earth. If something breaks on station, as all too frequently will happen, we've always got the ability to fly new parts. If you're going to the moon, you're going to be there long term. If you're going to Mars, you can't do that. You're going to basically rely on yourself. Now, the psychological aspect of going to Mars, there's another whole wrinkle to that, and that is the time it takes to transmit a signal from Earth to the crew on Mars, or vice versa. And you're limited by the speed of light, and it'll be a long, long time. Earth will become vanishingly small. It'll almost be indistinguishable from a lot of the brighter stars, so you'll feel very remote. So the psychological part of it would be kind of an interesting thing. To simulate that on station, that would probably involve essentially introducing a time lag between when the crew calls the ground and when the ground responds. It would involve, potentially limiting the crew's view out the window. So you're not seeing planet Earth. You don't feel physically as close to it. And it might involve even going so far as to letting the crew deal with emergencies and system malfunctions and work their way through them to a greater and a more independent degree than we currently might on Space Station. And there's a lot of discussion about how you might do that. It might be something that would be applicable, but I don't know yet about any immediate near-term concrete steps in that direction.
Mm-hmm. Don Pettit, you're going to be involved in the tracking and capture of Elon Musk's SpaceX commercial resupply ship, which is actually an historic event, the Dragon capsule, in a few days. What's going to be your exact role, and are you looking forward to this?
The short answer to looking forward to it is yes. It's going to be really exciting to have a U.S. commercial-made unmanned vehicle come and a rendezvous a station, and then we will lasso it with the arm and berth it to one of our common berthing ports. And so that is going to be a real neat piece of technology, plus the idea that we can have these vehicles come up and bring needed supplies. So all of that aspect is really, really good. In terms of what we're doing to prepare, Andre Kuipers and I are going to be doing the robotics to lasso the Dragon vehicle and then berth it to one of our ports. And I'll be flying the arm for the lasso part, and Andre will be flying the arm for the berthing to space station. So we're sharing the duties and backing each other up for this approach, track and capture, and then berthing to station.
Mm-hmm. Having lived, I'll address this to both of you. Having lived up there for many months, and having prepared so long for your voyage and your life in the space station, what did you find that you were not quite prepared for? What are some of the unexpected things that you say, gee, I can pass this knowledge along to the next person, or I found out more about myself from being up here for this amount of time?
That's a good question, and I've got a little example. One of these small details that you can never train for, and you are just surprised when you come up to orbit that it could be this way. And it has to do with our trash cans, our waste baskets. And we have these really nice waste baskets, and if you open up the lid to put a small piece of something in there, that little small piece of something will just be floating right under that lid, and then the next person opens that lid up, all these little small pieces come floating out, and it makes a big mess. And so the waste baskets are great for a big chunk of something, but all these little tiny things, like little pieces of tape and little strings and things like that, you don't want to put them in the waste basket, or they just make a mess for the next guy. So what we do is we take one of our little wet wipe containers, which is just like the wet wipes that you use for wiping baby bottoms on Earth, and we use the same ones up here. And they come in a little plastic pouch with a little lid, a little doorway that you can open up. And when we have one of those things empty, we stick it on the wall, and we use it for a small items waste basket. And you can open that little lid, and you can put little tiny things in there and close the lid, and you don't need to worry about all of these things swimming out. And I never would have thought that you'd use something like this for a little trash can, and it's an elegant solution to the problem. And these are the kinds of things that you only learn once you show up in space. And Dan, what do you think?
Yeah, I guess if I were to think back on the thing that probably surprised me the most, even having been up here twice on shuttle missions, is how difficult it is to keep track of everything that you have. On a shuttle mission, it's a little bit smaller volume. You do spend time in the station, but you don't spend as much time here that you don't get necessarily exquisitely good about keeping track of things. And up here, the first couple of weeks that we're around, it is so easy for things even that are velcroed and attached and so forth to just fly away, get bumped and jostled. We joke about new crews coming on board space station, shuttle crews included, creating a wake of swimming parts and cameras and notebooks and procedures and so forth behind them when they go by. It gets to the point up here where everything that you do, you're constantly thinking, planning, or at least in the back of your mind, how to keep track of everything. And if you're going to take something apart to fix it, for example, keeping track of bolts and washers and nuts and having a little piece of tape staged by and having all your tools organized is something that's kind of part and parcel with your life up here.
One last question. Dan Burbank, you're going to be coming back in a few days. Is adjusting to life back on Earth going to be difficult? Are you looking forward to it, or are you going to be nostalgic about missing the space station?
I think for everybody that's had a chance to be up here, I think you're always going to have just a little piece of your heart that's still here, that you're going to miss these views, miss just the nature of life in space. I'm really looking forward to seeing my family again. Family and friends, being able to see them again will be great. The thing that'll be really hard is, at least by all reports, is getting used to planet Earth's gravity and getting used to fighting it all the time. We spend a lot of time exercising up here, but I wonder if it'll ever really be enough to make those first couple of weeks as easy as I hope they would be.
Well, Commander Burbank and Flight Engineer Don Pettit, I want to thank you both for taking time to be with us today, and good luck to you, and welcome back when you get back to Earth. Thank you for joining us on Science Friday from the International Space Station.
Ira, thank you. It was great talking to you today.
Station, this is Houston ACR. Thank you. That concludes the event.
Thank you, National Public Radio. Station, we are now resuming operational audio communications.